It is. It is. And I don't say I have like profoundly profound new insights, but let me tell you what I've been thinking since Wednesday, because okay, I think we all agree that the question is what happens to a multi-premise argument, whether it's represented as multi-premise or through a compound claim, doesn't matter. But what happens when a single premise gets assumed as false, let's put it that way, whether it's just gets contested or and so on. But like we stop relying on that atomic claim underlying the argument. And what I'm realizing is when I said, let's have one row at a time, what I was doing was a kind of roundabout way of saying, let's have disjunctive normal form. Because it's about saying this, if any one of these premises fail, atomic premises fail, then that particular support falls. There might be another support, there might be another argument, another row of the truth table that supports a conclusion. That's fine, and that's the disjunction. But if any of the premise fail, and that means that the premise is treated like conjunction.
Yeah.
The one row at a time or disjunctive normal form are pretty much equivalent. And what I'm realizing is as long as we have, like we've spoken a lot about predicate logic, but the reality is we're mixing predicate logic and the notion of support, which includes non-absolute support, right? Predicate logic is sufficient condition. If this is true, that is true, basta. As opposed to, well, this gives me some evidence towards this being true, which is this more like our Boolean true thing. And the moment we accept such arguments, that means it's a very different story. Again, like we can say the conjunction of all these preconditions gives me one reason to believe. I could imagine another reason to believe using the exact same set of premises, for example, even without, not even another row, the exact same, and gives me another reason to support because I've got another reasoning.
Logic, you mean by reasoning?
Another logic.
Yeah.
And I kept saying, oh, if you have a defeater, we can negate the defeater and say that becomes another reason to believe because the defeater is not true, and then add it and then supersede the previous one. And in some cases, it will supersede the previous one because it's admitted that the defeater applies to that original conjunction. But in some cases, it's a separate thing. Oh, there's this other version with the defeater and it can coexist with the original. And it's just, if this one falls, well then, but this one doesn't necessarily. And that's, again, the conjunction aspect, the implicit conjunction aspect. So I'm really thinking that conjunctive normal form is a very important part of the game. Now, where does that leave formula? The advantage of the formula is that it's a synthetic way to put a lot of rows together, in that it's about saying this combination of truth value for the premises yields this truth value for the conclusion, and this other combination yields automatically this truth value for the conclusion. So it's a way to treat
many conjuncts conjuncts and disjuncts together.
Yeah, exactly. It's a way to treat many disjuncts together. It's economic, and it's a way to subsume. And again, we can argue about formula. And again, it's interesting in that some formula may embody causal mechanisms. And here we're at this interface between causality and logic. Like when we say, and I want, before I get back to formula, I was thinking, okay, what about necessary conditions, right? Well, if I say A is a necessary condition for B, in logic terms, what I'm saying is not B implies not A. So the logic arrows runs the other way. But it's possible that it still makes sense to say A implies B necessarily, because that's where the causality arrow runs, right? So the logic arrow and the causality arrow may be at cross purpose, is what I want to point out as an example.
I'm not certain I can follow that part.
Okay, if I'm saying A causes B and it's a necessary condition, meaning nothing else than A causes B.
Mm-hmm.
In logic terms, what I'm saying is, well, if B didn't happen, probably A didn't happen, and not B can be used as evidence for not A, or as support for not A. If you just take the how you would encode it in logic, which is a bit an atemporal, and in argumentation and epistemic, why do I believe this? You go from B to A, not from A to B, but the original causal link may have been clearly, and in my example, was clearly from A to B. A causes B, and it's the only way to do it. Maybe that's true, right? And in which case, we have causality going from A to B, but in a given argument, I can say, well, not B, hence not A, and that means that the logic arrow goes the other way around. And that's why I keep saying, when we do the argument tree, it's perfectly valid to do so, and it's important because it's a real representation of how argument happens and how we think, but it's good to correlate it with the causal graph, because this is another way to consider the same argument. And in some cases, one will be easier to reason about, like looking at a causal graph may be easier to reason about, even though we'll have approached it through the causal tree, which may be structured very differently. In some cases, the other way around. So that was my general causality. So let's go back to formula. A formula, we can have a formula which is bridging many disjuncts, many ors, many rows of the truth table. Well, a formula is also expressing, well, this is how I think these factors fit together. And in that way, that's at the causal level. I'm bringing all of these factors together and saying, well, it's A and B or not C, because it's not just a formula. There's behind it probably often a theory of how these factors interact. And that's at the causality level. And the fact that you can derive the rows of the conjunctive normal form from the formula, it's still a different domain, and there I'm with you, than saying, okay, well, the disjunctive normal form is at the argumentation, in the argumentation domain, and the formula is in the explanation, some of it may be causal, some of which may be epistemic also, even sometimes. I mean, it can, but it's another domain. But I still think we can use conjunctive normal form with the understanding that we have non-absolute support, right? This and this and this is one reason. It's not the only reason. It's not an absolute proof. It's just, it can be vague support or it can be absolute support, right? It can be sufficient or not. It can be sufficient or not sufficient support.
Yeah, that's the flag we added, you mean, right?
Yeah.
It proves conclusion. Okay. Yeah. Yeah, I think I understand the gist of it. But that was only one part. That was whether or not we should model function in the argument model. That's one part. The other part we were discussing was as well, like, how do you model conjunction? No, that solves one issue. And I think I follow your logic with that functions model causality. I think that makes sense.
By the way, speaking, one thing you said at some point is we want a compound claim, like if we don't have multi-premise explicit, and I'm still struggling with that one, we don't want compound claim in the conclusions. I'm still a bit hesitating on that. I could see, for example, at the causal level, A causes either B or C as a valid causal link. How will I represent that in the support refutes logical argument?
By or, you mean one or the other, but not both?
In one case, yes, certainly.
Because if it's both, you just add it to both, obviously. But
Yeah,
if
that's
it's one or the other, I mean, it seems like a modeling causality there again, right?
Yeah, yeah, I did say explicitly. Suppose you have this causal link. A causes either B or C.
But then the question, I think, is like, do we really want to model causality?
No,
Can we model causality in
well, the question is,
a model than like this? So give some support for, do these live side by side, I think is a question.
It's a perfectly valid question, but what I'm saying is this causality link can be used as support to an argument link, right? This causality formula can be used as a support for an argument link.
Oh yeah, okay. I guess if you express it as a claim, yeah, why not? But then that's a progressive formalization where you could, yeah, I guess that could work, yeah.
Yeah, but what will happen is, oh, by the way, B, so possibly A. So we get into all these. But again, is that I was trying to make the argument that since this is a possibility at the causal level, is this something we absolutely want to exclude at the logical level, saying, well, A support could be supporting either B or C. Okay, let's take the, let me take an example from a real life mathematics argument. I think I went through that one. We want to, is it possible for an irrational exponent and irrational to be rational? That's the classic intuitionistic logic example. So take root 2 exponent root 2. Now root 2 exponent root 2, it may be rational or irrational. If it's rational, we've proof complete. We have an irrational exponent, irrational exponent, irrational gives a rational. If it's irrational, we can take that number, put it exponent root 2 again, and now we have root 2 exponent, root 2 exponent, which ends up being 2 rational.
I don't think the specific example is the greatest example because it's not an argument. It's like you're modeling logic, exactly, right? And I understand that it is also a mathematical argument, which is primarily modeling logic.
No, what I'm trying to say is it's, if you want, there is an underlying argument form here, which is about supporting a disjunction. It's saying either root 2 exponent root 2 is rational or irrational. We have a disjunction, and either of them, like this disjunction as a disjunction, which is fascinating, can be used to support the conclusion it's possible to have A and B irrational so that A power B is rational.
Sure, but in an argument model, couldn't you just write this disjunction you're referring to that you want to use as a claim here? If you write it as a claim in natural language, wouldn't you say something either A or B, like in claim form?
What I'd probably want to say is, and that's what I'm asking, how do we write this?
How to write it is natural language. The question is, first of all, do we want to allow writing it as natural language? And second of all, do we need to formalize it further? If so, why?
Right.
And if so, why? The answer again is so you can calculate the conclusion, right? So you can infer the conclusion from the atomic A and B.
Right. The question is if we take the disjunction as being instrumental in proving the final claim, what happens is because it's a disjunction, the question should always be, what happens is one of the premises is proven false, right? In this case, saying it is false that A, which is root 2 exponent root 2 is rational, it turns out that it does not disprove the premise, but then we lose one branch of the conjunct. But in this case, there's a separate claim, and I'm not sure how to model that. It's that one of A or B has to be true. And this is what the OR is about, right? You cannot have both A or like A, it's actually,
but all of
it's
it,
actually not A.
like Antoine, isn't all of this attaching proofs to claims? Because that's what I concluded after the last meeting. I really think all of this is relevant, but all of this I see as features which are proofs, parameterized proofs, maybe, that as inputs take claims that calculates the conclusion. I think that all of this, what you described, does that. And I think it's super relevant because this is a useful tool. If people believe in the proofs, this can help them guide based on lower level input, or maybe things they've already expressed belief on. It can tell them, hey, but wait a minute, here are some proofs that prove actually that you should also believe in the conclusion. If you believe in these proofs, you follow this logic, you should also believe in the conclusion. I really see it as
so
that.
Like, I think that's what we're struggling with is, you know, on a more simple and fundamental basis is you have a conclusion, which in an equation is the equals part, right? It's the outcome of the equation. But there's lots of ways you can support that. You can support it through a mathematical equation, or you can support it through argumentation, which we've discussed with the height examples or whatever, right? So you have a claim that isn't the mathematical formula. And the claim is something is something. And then you have a desire to prove that conclusion through mathematics or logic, right? Which ends up being the I'm not saying always, I'm saying this is an example of a way you could try to prove that conclusion, right? You say, well, look, math says, I mean, these things we see on Twitter, math says this, right? Okay, so how do we want to support that in our system? Do we want to just say, well, you know, through F equals MA, you know, M is this and A is that, and therefore the conclusion's right, and then have people just sort of upvote it, right? Or do we want a more formal link to that where, you know, you have a formula and you can debate, you just debate over the values of M and A, which are obviously claims. The value of M is something, the value of A is something. Those are claims. We know that. Then the debate, I guess, is really, is this the right formula to apply in the situation, which is, in my terminology, a relevance discussion, right? How do we do that? Well, okay. How do we do that without having a formula? Do we need the formula element to simplify all that and make it more clear? Or do we do it through text, simpler claim and support forms?
Listen, part of what you've said, I've just in a way agreed with. And part of it I disagree with. In the sense I've said, yeah, okay, fine. Formula are their own domain. And they can be used to, basically they're part of the argument that we use and why we say that this justifies that. Fair enough. And there's a kind of inherent structure of, but there is also the kind of fundamental argument structure, which is saying this belief is supported by those beliefs. And what happens is what if one of those beliefs fails? And this is something I think we do want to capture in the argumentation domain. This
that's the, is it necessary and is it sufficient? Those are two like things basically you're asking for them per support.
Or are you talking about like on my level where, oh, no, mass isn't 5, it's 10. That is a fact that changes, you know, if it's true or not, changes the results of the support.
Okay. Yeah. Basically, we're speaking about dependency relationship between claims, right? If this claim falls, what other claims, what are the next dominoes to fall? And we can do it as dependency, we can do it as defeasibility, which is the opposite, right? We can do it as a combination of both support and defeats. I'm not sure defeat is exactly the negation of absolute support, but this is a good conversation to have, actually. And we certainly agreed that there's many flavors of support, at least two, right? Absolute and the necessary you could model through not B implies not A as a separate claim. Not B necessarily says not A, to say that A is necessary to B. So support and absolute support are sufficient, and we agree that support can have any premises. But the real question is what happens when a premise falls in the support? And right now we're kind of supposing disjunction, conjunction at the level of the support. If it's more complex, we have another row for another case where that premise, for example, if it's false, we have a lower support. Like, so let's say A and B strongly prove C, but A and not B weakly proves supports C. It doesn't oppose it, but it supports it more weakly. That's okay.
You're talking about scoring, right?
No, I'm talking about trying to
what happens if it falls. It sounds like you're talking about what happens in terms of the conclusion. If, like, how should the conclusion be interpreted, or also how would you do roll-up scoring?
Yeah, okay, what I'm hinting at, I wouldn't call it scoring, it's this believability, you know?
Say this, scoring is a way of mathematically reflecting the concept he's trying to get at, which is you should believe it less if you don't believe the underlying things. Yes.
Yeah. And if something is necessary and it is false, regardless of how you measure that, either through, let's leave that out for now, then you want to say that has a bigger impact on that believability. But I mean, in general, I think that's what we've been calling scoring. And I agree that these are features that are needed. If you want to do that, you need to have that information, whether or not something is necessary, and you need all of this. But at the same time, it's also the big thing where I struggle with, because it adds an extra dimension of, again, disagreements. Like you can add a claim all of a sudden as a claim, which is by itself not sufficient, and somebody else can add the same claim and state it is sufficient, etc. And so I'm not saying that I understand your argument that if you want to do scoring, this is needed, because this is a major factor on actually calculating believability in terms of what I would call truth, calculating truth. But at the same time, I've always said calculating truth is not a primary concern for me. Because of many of these reasons, it complicates the domain a lot. So I don't know where that leaves me, because I also see the problem. Well, if you don't model it in the arguments, then how can you do scoring? So
yeah, exactly. Yeah. There's an objective way to deal with this, which is, okay, it's in a separate domain, or okay, it's not one of the core functionalities that you require. But again, what does implementing scoring look like without that? That's always the question. What would the data model or the the instantiation look like? And then trying to apply scoring onto that, is that still
possible,
doable?
And can it be done cleanly as a separate layer, or do we have to alter the core layer? I mean, that's the other question, because clearly scoring is something it's true. I'm less interested in scoring than dependency mechanism. I'm less saying this is true than saying the truth of this depends on the truth of that, which is a more limited scope. No, it's not the same, because in the first case, you're trying to achieve a believability score, which is, here's a number. Whereas what I'm saying is, well, if this falls, that falls. It's a dependency relationship.
Yeah, but the reason
It
you're
doesn't
modeling it,
entail
the
a
only
number.
reason you're modeling it is to enable, the so that here is to enable calculating the former you're mentioning. If
No.
you
Well, the difference
No.
the difference is that like you can create a dependency graph. If the question is whether or not you need more information in that dependency graph, right? If you just need to know what things are connected, you don't need any advanced parameters on your connections. But if you need to know that this connection is a must-have versus it's interesting, then you need that in the structure to capture, right?
Yeah, what I'm saying is,
but again, what other reasons than formalizing something as this is a must-have are there other than automatically having the system act on that must-have to then calculate the outcome of the conclusion? I don't know any other
automatically
reason.
act, yes, but calculate a number, no. What I'm saying is I can have a system where I will show this is threatened, this is threatened, this is threatened without giving any quantitative assessment.
This is what, red? This
Threatened.
threatened.
This conclusion is threatened because its premises were threatened, right?
Yeah, but how do you know the premises are threatened?
Because I've got the links. That doesn't mean I've necessarily. No, what I'm saying, no, what you're saying is the only reason to have the links is to calculate a number. I'm saying no, the links can have its own value.
Yeah, but the question is, do you
number or not? Whether
are you wanting to say how threatened? That's the question. Are you wanting to say how threatened or how it's threatened, as opposed to just generically there's something threatened underneath? Those are two different things, right?
But
yeah.
and even I don't get the input values if you don't have output. Like, how do you calculate the whether or not they're threatened? Based on what? Because this is a recursive structure, right? So what's the input?
No, it is about saying, if I don't believe this, then I have no reason to believe this, and this.
Okay, so
yeah,
assume binary scoring. You have two claims. They both need to be true, otherwise your conclusion cannot be true. So yes, and this is what I'm saying. Somebody, either an individual or aggregate, doesn't matter. Let's take individual. It's easiest. If an individual says A is true, B is true, then you will says, oh, that means C is not threatened. That's pretty much the same as saying C can follow. If you then say the same person says B is not true, oh, C is threatened. In what way are you not doing a calculation based on your input? Whether or not this is probability, a number, a Boolean, I don't care. But you're calculating based on input values and output value.
I'm saying I agree it's a calculation. I agree there's a result, but I'm saying it's not necessarily a probability estimate number. That's all I'm saying. It's not necessarily a score in the sense of, oh, so the probability of believing this is 0.7. That's what I'm explicitly saying.
It also begs the question: how does this work recursively? Do you take that number as the input for where this conclusion?
Yeah, and this is why I'm not sure I want to do numbers, but I do want to say, there's uncertainty here and propagate the uncertainty. Yes, that's a calculation. I'm never denying I'm doing a calculation and, showing something to the user as a result of this calculation. I'm saying the calculation may not take the form of a numeric score. That's all I'm saying.
Yeah. Yeah, which fits the function thing we started earlier with, that if each claim can have functions, then if you believe in that function, then that can tell you something about the conclusion, which I still think is valuable. But that's why I see it as separate. I don't see it as.
What I'm saying is there's a level of calculation for numeric scores or numeric values, which is a separate domain. And I agree with you, it's a separate domain. And I'm saying numeric score is separate domain, but I'm saying that you can do dependency relationships in the core domain, even if you push score calculation to a separate domain. But you can do dependency calculation in the core domain, or at least the domain I consider core, which maybe for you is not core, but that's fine. But the question is, how easy is it to put it in a separate layer?
Yeah, we'll recurse on. That's my main question. So if you do dependency, if you do this in an argument modeling layer, the only way I see that works is if you only do it one level deep, or in other words, one function deep. Like you can only say, and any given claim you're looking at, all the different functions or logics or dependencies, whatever you want to call them at that point. If you only want to model dependencies, I don't think you can recurse on that.
Why not? I mean, I'm saying that's something,
Because then you need to, how do you recurse? Like if the outcome is it's threatened, do you then assume the input for the next as that claim being true or false?
I'm saying that that claim is now uncertain, and then propagate uncertainty.
Yeah, it would be nice to have a visual example of this.
A truth table. Well, truth table with uncertainties have been done. That's not exactly mysterious, right? Basically, uncertainty is extremely well, true or uncertain is true. False or uncertain is uncertain. Blah blah blah. It's not difficult. Ternary logic is very classic, actually.
While you guys are talking about that, I'm also thinking about what I was saying about the use of formula and where that would fit in. And one thing that I'm starting to realize or starting to consider is that a formula, a claim with an embedded formula should not exist.
Okay.
Like that's not a claim. That's a formula, right?
Formula distinct.
Right. Which means, like, we were talking about having the logic formula inside or as part of the structure of a claim, and I don't think that should be the case, because the claim is the equals, the output, right? So, and there's more than one way to support that claim, that output. It doesn't make sense to have a claim that is a formula. Instead, you can support claims with formula. A formula is something that has an output, right? And has as input claims, right?
And the output is a claim.
Each input value is a claim. The output is not a claim. The output is not a claim. The output is automated. The output is a calculation. It's derived from the input claims. It's a compound claim. We could call it a compound claim. It's not really a compound claim. It's a compound structure of claims that are inputs to a formula, right?
I think it's a claim in that it can be used as input to support. It can be used. We can disagree with the output independently. So I think the output is totally a claim. It is a claim which happens to be the output of a formula.
What do you mean by the output is a claim? If a function proves an output, do you just mean that the output, the thing being proven, is a claim? Is that what you mean? Or maybe you mean something different? Because
okay. Really, the claim is this formula, this output is to be believed or as the right formula or the right thing for what we're trying to do, which is why it's a support of another claim. It's not. Okay.
Here's how I see it. First, let's take the stupid Fm equals ma because it's simple. We all understand it, right? We have the mass is 5, that's a claim. Acceleration is 5, that's a claim. We have the F equals ma, that's a formula. The formula takes those claims as input in this, in this specific context, blah, 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 and will output something which says force is 25, and I'm not naming this something yet. That's something, I can use it to support something else. So it can play the role of the claim as an input. So that way it is a subclass of whatever we use as input of support. So that's what I call a claim. That's this. That's
Okay,
It's a premise.
Okay,
It's a premise.
no, one
or
second. Premise is
something.
a role. It's not a
Yeah.
class. Let me
there's
finish.
a difference here.
I'm
There's
not
a
finished.
difference
I'm not
here.
done.
Does
I'm
your
not done. I'm not done.
what
I'm
is
not
the
done. I'm not done. I'm not done. I'm not done. Thank you.
yeah, okay.
Now, don't
back to you.
argue. Don't argue until I'm done. There is an implicit support there that says the formula is valid, which is itself a claim. The formula is not a claim, but the formula is applicable as a claim. And there's a support structure that says, because we accepted these two inputs and because we accepted that this formula was applicable, that is supporting the acceleration is 25. Okay, now I'm done.
That claim that it's valid is the support. The support doesn't use that claim. That claim is the support, because that's the point
That's
at
what I
which
said,
you
yeah.
argue, is it useful or not? Right. No, but it is exactly. The support is, this is useful. But the output that F equals MA, if you've shown that that M is 5, if you've validated those two claims of M and A, right? There is no debate about F. There's no debate about F. It's not a claim.
It's a really bad example because this is a function where the output is generated. I think the other examples we're looking at is that it's modeling logic. It's like,
but logic, you can have logic functions, right?
Yeah, but do we allow a claim that outputs a value, like, and based on the input, like, is the function, the thing you're supporting, right? Is that fixed like F? Or does, depending on the input,
No, the thing
the
you're
output
supporting,
change?
the thing you're supporting is the result. The
Which
thing
is
you're
fixed, right?
supporting.
So in this case, if
Yeah,
you
it's
want,
fixed.
if you want to,
It's
in this
fixed.
example, F is MA, you would have a claim that says F is 20. That's the claim. And then you have a
No,
function.
but you could have a claim like, you know, we have we have enough power, we have enough strength to move this thing, right? So it could be simply, you know, rather than force is 25, it's more like we need at least 20 and we have that.
Yeah, but then your function is different. That's what I'm saying.
Your function isn't different. Your function, you go, oh, I can prove it. F equals MA. I'm going to prove it through F equals MA. Our M is 5 and our A is 5.
So how do you implement this?
I proved. Well, you have a formula, right? This is some sort of object we'd have that's a formula, an entity that I don't know. Somehow it has to act as a premise.
So I'm already thinking how you would implement and run this logic to come to the conclusion. And that's where.
Well, no, you define, I'm going to support it through a formula, right? Look, I'm going to prove it through math, right?
Yeah.
And my math is F equals MA. So I've created this
but it's
structure
not, it's not, you need a lot more to prove the output, the claim you just said you want to target, maybe under the cover somewhere use F equals MA, but it needs a lot more than that. You're going to need to do a comparative.
That's the debate. You're going to say, no, look.
Something at least.
F equals MA and our M is 5 and our A is 5, right? So you can debate whether or not our M is 5 and you could debate whether or not our A is 5. You can also debate whether or not that formula you're proposing is a good formula. That's a separate, that's in the support. You're attacking the support of the formula. You're not attacking the number output of the formula because you instead you debated the inputs.
No, okay.
You debate the inputs and you debate whether or not the formula is the right formula. You don't debate the output. You understand?
You can't.
You guys are hand waving what the formula is. You're just mentioning F is MA, but how?
That's the formula.
No, sorry.
That's the formula. F equals MA.
Stop again. I didn't get across the first time. I'll try again. Because when you say you're not debating the output, I heartily disagree. You might very well debate the output. Say the force is not 25, it's 30. You miscalculated. You miscalculated the speed. You blah, 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 blah. You can debate the
No.
No, once again. And I agree with you that debating the result is not the same as saying this is not the output of the formula. That is a different debate. But and what you call the result, I'm not sure that's an object, but what I'm saying is there's this output fact, which I'm saying is totally a claim, and I really don't see how it's not a claim, which is output fact acceleration is 25. It's a claim because I can contest it. I can say, no, you got that number wrong. It's not saying that the formula is wrong, which is, I agree that you cannot do. You cannot say that the result is not 25, but you can say this does not fit reality. So I can attack it. Thank you very much. This is not the force that is measured by some other force measuring.
But you're attacking that. Okay, but you're attacking that through the support. You're saying you've got the wrong formula here because it's 30.
You've got the wrong formula, you've got the wrong mass measurement,
Okay.
you've got whatever wrong.
Or you're attacking it through the M or the A, right?
Exactly, exactly true.
You can't say you put in 5, and it spits out 25. You can't say, no, 5 times 5 is 30. That's not a debate. You don't have that debate.
I agree with that, but I'm saying the output is still a claim, even though there's this maybe thing in the middle, which is the result.
No,
yes,
the output is not a claim. The usefulness of the output is a claim.
No, what I'm saying is maybe you have this weird thing in the middle you're talking about, which is the unassailable result that 5 by 5 is 25. Okay, fine, but the next step after that is transforming that into a claim, because otherwise it's useless.
Exactly.
It's not transforming it into a claim. It's transforming it into a support. There has to be a claim
at the other end, because
it's
otherwise
transforming it into a support.
A support has a conclusion. A support always targets a conclusion. That's a claim. Yeah, exactly.
No, but it's targeting. No, it's targeting whatever the other claim is. It's targeting whatever the claim. Well, like I've said, we have enough force to achieve this, or the force is 30 is a claim.
Yeah, but
right?
now
the force is 30.
The force is 25 is a claim too. Somebody could have said that independently.
And you support it by doing look. I will support it by showing F equals MA. Okay, let's take it the other way around. Let's take it the other way around. Somebody says the force is 25.
Yeah.
Create an argument that supports that.
Mm-hmm.
Create an argument. What are you going to do?
Oh, and I'm perfectly happy to use, but what I'm saying is what I will do is create a support thing that uses the A equals 5 claim, the M equals 5 claim, and the F equals MA formula, and say all those claims are supporting the A equals 25 claim.
Okay,
that's what I'm going to do.
The support. What I'm saying is that that's not a separate instance from the support. That is the support. Because any debate you have, about that is not on the factual.
I made a mistake when I said it, so I'll amend a bit. There's a claim that F equals MA is the appropriate formula to use, and there may or may not be either a claim or a mechanism, and that's the question: is it a claim or is it a linguistic claim or a mechanism that says, and by the way, the F equals 25 is the unassailable combination of those premises through this formula. Given the 3 claims, this is the right formula, this is the applicable formula, that's a claim, which refers to a formula which is not a claim, which is a mechanism, and the 2-number premise. But the formula may or may not be operational in the sense of saying, oh, by the way, the result is 25. That's because that's a separate domain, which may or may not be implemented in the given system. It could be a human saying, by the way, I calculated and that's 25, or I miscalculated and that's 30. And then you can, say there's a mistake, or even if it's being calculated automatically, oh, damn, Intel inside 25.00001. There was a rounding error. It happens. These are all, but where I do agree with you is there's a distinction to be made between the connection of 5, the formula, and 25, and that's maybe not a claim. But what you get at the other end has to be a claim, because I have to use it as a premise to something else, no matter what else gets created as an intermediate result. That I'm sticking with.
And that's what I'm saying, though, is...
No, it's not. I've been fighting with you about this.
No, but how do I put this?
Do you intend to run the formula or not?
The
Only describe
formula claim, as you say, right, is useless
appropriate
as a
method.
standalone. You don't debate the claim when it's like that. There's no, that's not true, because it is true by definition. You debate the inputs,
the context actually.
and you can debate whether, and that's what I'm saying. You debate whether or not it's useful. You debate the inputs, and you debate whether or not it's useful. And the debating whether or not it's useful is for what? Support. That's how you debate a support. Is it a good support? Is it a bad support? When we say contextual in this context, we're talking about support, right? It's being used to prove another claim.
No,
But this
saying,
element F equals MA with the 5 and the 5 as inputs is useless on its own. And nobody's going to debate that. Nobody's going to say, nuh-uh, because there's no reasons. The only reasons that you can debate in that case is your M and your A, right?
Okay, let me put it another way. I can attack the claim acceleration is 25. And I'm not attacking the calculation. I'm just saying, well, you know what? Force is not 25. I don't know which of mass or acceleration is wrong, or maybe you forgot the relativistic term. I don't know, but I know that the result is not 25. I'm not contesting the structure of the support, because that's a separate operation.
Yeah.
I'm contesting the conclusion as a claim.
No, you're contesting it as a support, because if you know it's 30, how do you know it's 30? That's either you're doing totally circular logic. I know because I know, which is not a good argument. Or you're saying it's 30 because something else. And when you're saying it's 30 because something else, you're saying this is a bad formula that shouldn't be used because this other formula is better. Or this other reason shows that your output is wrong.
I think it should be allowed to argue with the conclusion, even if you don't know the reasons, before you have reasons. But that's another thing. But that's not the case I want to argue right now. What I want to argue is I could say I've measured the force with whatever force measuring widget, it's 30. Thank you. And I don't know what's wrong about the original support argument, but I know something's wrong because I got a different number. Or maybe I know that the number is contestable because we have conflicting measurements and we have to check all our measurements, which is a valid argument. And here,
no, of course, but that's what you're doing. Where do you debate that? Okay, let's say the claim is the force is 30, and you support it with my instrument here shows force is 30. Yeah. And someone else says, no, I measured the mass, I measured the acceleration.
They're 5 and 5.
And I got 5 and 5, and that is 25. So I oppose your statement. Where are you holding the debate then? You're either going to debate your claim that you measured 30, or your support, which is, your instrument
about the accuracy of my
or you're going to debate, or you're going to debate mass is wrong. You measured the mass wrong.
I'm not.
Or you're going to debate, no, you need to use an Einsteinian formula here, in which case you're attacking the use of the formula. That all fits into the structure that I'm saying that the formula is only useful within a support.
And what I'm saying is the end result is still a claim. But by the way, I just want to say there's
the
also
conclusion is a claim. The conclusion is a claim. Wait. What is the end result? Tell me the end result. No, tell me the end result.
Yeah, the end result is a claim. That's what I kept arguing, and for a while.
Say what the end. I don't understand what you mean by end result. Is the 25 the claim?
It's not a claim. At some point, there's a claim A equals 25 that comes out of the support. The conclusion of the support is a claim, even though.
The reason I say it's not a claim is because you don't debate that number that came out. You debate the inputs or you debate the usefulness of the formula, but you don't debate the 25.
I still disagree. That
How do you do the translation of the output number, Timothy, to why it's a support in the first place? Where does that magic happen? So you have an output number.
Any
you
support is
A25. How in your system do you do the translation from that number you apparently can calculate, which is already a tricky part, but leave that aside. How to extract
it depends on how you want to formulate. It depends on how much formalization. You don't need to translate anything.
Okay, so but that's where I think the big disagreement and confusion lies. Like, what is this function? Is it just plain text? Is it something the system will run? Is this something that automatically
let's think about it
and leads to a result in terms
let's think about it in terms of incremental formalization, right?
Yeah.
Let's just say someone says, we have enough force to make this happen, right? And they just use the words, right? Okay, you've defined what this is, but there's no numbers involved in there. It's just a statement, right?
Can you say the statement to be concrete?
We have enough force to make this happen.
Okay.
Right? We have enough force to achieve escape velocity, right?
On a very small steroid.
Right. Right. Okay.
That's a claim, right?
That's a claim.
Okay.
Right. And I say, whatever. I disagree because the max force we can get, you know, I can oppose it by saying, here's our force, F equals ma, and our m is this and our a is that, right? So what I'm doing is I'm making two claims here. I'm making our claim. Our mass is only 5 and our acceleration is only 5. It's a bad example because that's not rocket science. It's too simple.
So,
but anyway, you get the point.
So, but if it's, you're not formalizing anything, so it's pretty much the same as adding a support.
Well, yeah, here's the thing, right? So I could just write a sentence that says, hey, F equals ma, and instead of escape velocity, let's do something more real. We need to put a stone on a pressure plate that will, you know, trigger something, right? Is this stone big enough? This stone is big enough to trigger, right? And I say, okay, well, in this case, it's multi-premise. We need 10, we need 15 newtons, and this stone is 5 kilograms. And acceleration on this asteroid or this on the moon is 5 meters per second squared, right? Okay. The claim: this stone is big enough to trigger the plate, the pressure plate. That's the claim. And I say, I can prove it. And I'll either say in words, well, F equals ma, A on this planet is 5 meters per second squared, and this stone is 10 kilograms, and we need at least 15 newtons. And there, that's a very wordy, claim, right?
Yeah. And then you can support and oppose that by adding no, you disagree simply with the values used.
And here's where that structure is not canonical, because I want to say, no, the stone is only 1 kilogram. No, the acceleration on this planet is 2 meters per second squared, right? So already you see you want to break that up into atomic parts that you debate, right?
Which
okay. Now, here's where we're increasing formalization, because
but the form you just said had that problem. I mean, it's not like the way you just said it with less formalization didn't solve it either, right?
The way I
specify concrete values and.
Well, it did not solve. It just created a new problem. I made an argument, but it was a wordy argument, and it doesn't support canonicality because you can't debate each individual.
So now, how does a function come into the picture to solve that problem, which I think is your goal?
Yeah, in this case, there's two premises, and I can't say, but it's the premise is F equals MA, and the other premise is, and we need whatever 10 newtons or more, right? Those are the two things. I mean, maybe that's, I don't know where that 10 or more comes into play in this case. But anyway, you have this, yeah, because F equals MA, and that F is sufficient. Those are the two parts.
But what
and
F? Where do you
say,
specify the F? It doesn't. I don't see how this solves that. I mean, you still need to specify the F at some place, and people can still disagree.
no. You because what your F equals MA in this case is a special structure, which is a formula structure, right? The formula structure would be, if I were modeling this on one of those graphical input things, would just be a calculation, M times A, and use whatever the result is, right? So, and then I would plug in M and A, which are my claims of M and A.
Where do they come from? Who plugs
I would make a claim.
and
no, because I'm creating a more formal structure, I would do it. I would go,
yeah,
I want to use
how
the
does
F
it
equals
solve
MA.
the problem we started with? I mean, one person adds one formula and they plug in M&A, and somebody else adds the same formula and plugs in different M&A. How is it this different from the problem we started with?
You're pulling out a separate problem, right? If we don't want alternative proposals, you just want to invalidate that argument.
Yeah.
You can invalidate it by saying, you said M is 5, but M is 1.
But you can do the same in a non-formalized form, where you just write out the numbers in plain text and then you add an opposing thing. No, M is, I mean, I don't see how it solves it. You just move the no M is whatever to the specific M. I mean, you move it to a separate claim. That's all you're doing. But the claim, I mean, you still have non-canonicality.
No, the point is that you have some sort of structure here on which multiple claims depend upon each other, right? That's what we're discussing. That's the compound claim thing we're discussing, where somehow it's the combination of these elements and the way they work together that together creates a valid support or invalid support or something. That
it's a calculation. Right? So if you don't do the calculation, it's useless.
No, you do the calculation. What do you mean?
Yeah, if you do the incremental formalization part, but then you still need to, the thing you calculate, and that's where the confusion with Mike and Tuan and I am still not certain where the confusion lies, but that's somewhere there. Like, okay, what do you calculate, and to which degree does that calculation then, what is that? Is that the claim, or how does that support the claim? Who makes the connection that that thing that is calculated supports or not supports the claim? That's, I think, where we get lost.
I mean, I see it in my head as a kind of premise, right? A formula-based premise that you connect claims as inputs through some sort of thing. It produces an output, and that output can textually function as a claim using a support, right? So in other words, you've created this formula here, F equals MA, this thing, and you've connected the inputs MA.
The relation between that resulting claim is the
it's the same thing we said with the other compound. It's the same thing we said with the other compound claims, which is a compound claim is not a claim because you don't make arguments for or against it. You only make claims for or against its inputs.
No,
right?
it's not
the same thing.
It's not the same thing. It's not the same thing. I agree. One second. I agree that when the formula spits out A equals 25, which I argue is a claim, it also spits out a kind of magic support object, which is saying this formula and those premises, input values, absolutely incontrovertibly supports that conclusion. That one is the arguable part. That's the support part. But the result, this is still a claim because it's still subject to, I can still attack A equals 25. I cannot attack the fact that it comes out of those premises, but I can still attack it as a thing in itself.
No, you're attacking you're attacking the inputs or you're attacking whether or not it's the appropriate formula for
Which is absolutely
a
correct.
conclusion you're trying to draw.
That's absolutely correct. I've never denied that, but that doesn't mean that I'm not attacking A. And then that makes it a claim. If I can attack it, it's a claim.
No, you're attacking one of its elements.
No, I'm attacking A. I may not know which element I'm attacking yet. I'm just saying this is false. I still have to find out what premise is wrong. I can still attack.
No, but
A
it's
without doing
false
it.
only in its use as a support. It's false only.
No,
it's only
I can
false
say
because
it's
you're
false in
proving
and of
something else.
itself. You keep bringing it back to, oh, that's in its use as a support. No, that's your thing. I'm saying I'm attacking in and of itself. A is not 25. That's a valid move to make. I don't see how it's not a valid move to make. And I can say, I think it's false because one of the premises must be wrong. I don't know which. I won't attack a premise yet until I know which, but I still think it's false. We said we would allow people to write things that are not even logically consistent and just show the discrepancy. This is one such case. I want to attack the A equals 25. I don't know which premise is wrong yet, but I can attack it before I know. And that makes it a claim. I'm not going to budge for that. I can agree that there's a support structure which is uncontrovertible, which says how this 25 is related to other things. That's fine, that's not touchable, but the conclusion is still attackable in the meantime. And that's,
all right.
I'm not even having a discussion about this. It's ridiculous. Why can't I disagree with the conclusion? I just did. It's a fact, I said it. I said it's false. It's a statement, it's a claim.
Okay, but because I think we're disagreeing in what is the claim, right? I think that's the problem.
Yes,
I mean, it's somewhat of a structural thing, and I have a hard stop. I'm already late, but
yeah.
I agree. The thing you're talking about is a claim that is arguable, and you can argue against it through any means you wish. But
Or
the
none.
formula structure
Or
itself, you don't. This formula structure with the number at output, you don't.
But I'm saying that thing
Then
that you said
we
I can't argue with is not the same as the result. It's not the same as the output. And the output is a claim.
No, the output being useful is a claim. The output being useful is a claim.
No,
right?
no. The output is a claim in and of itself in its own right.
All right, I hard disagree. But
abstractly.
Yeah, I have to go. I gotta. Yeah, okay.
See you on.
I'll put up some examples to show because I think we need to visualize.
Yeah, and also definitely
better.
think about how to implement this because it's been a very lengthy discussion for something that's incredibly hard to implement and has a huge impact on how the user even can interact with this for what I would call a minority of arguments. But okay. See you on Tuesday.
Bye.